Welcome back, everyone. Having explored how the Islamic Golden Age bridged the gap between antiquity and the Renaissance, we are now broadening our horizon even farther east. Today, we look at two of the most sophisticated and enduring civilizations in the human history. The scholars of India and China were developing their own unique way of measuring the cosmos, navigating the ocean, and understanding the earth. In this lesson, we will examine the mathematical brilliance of ancient Indian scholars and the incredible cartographic and maritime achievement of the Chinese dynasties. It is a story of independent discoveries, advanced engineering, and a deep philosophical connection to the landscape. Let's begin our exploration of the Indian and Chinese contributions to the geographical thought. As we begin our study of the Indian contribution, we have to look back much farther than the medieval period. Geography in India didn't start as a separate science. Its traces were found in the Vedic text. In Aryabhatta, for example, we find some of the earliest attempts to categorize the region of the Indian subcontinent, marking a foundational step in regional geography. By the time we reach Satpat Brahmana, we see something even more sophisticated, a systematic approach to describe the different branches of natural world. But the real turning point for our discipline comes with Surya Siddhanta. This is where we first see the term Bhugol. It is a powerful word because it literally translates to the round earth. It signifies a shift from purely descriptive geography to a mathematical one. The author of Surya Siddhanta wasn't just describing the land. They were defining the earth as a physical entity with a specific surface and structure. This text set the stage for tradition that would eventually produce some of the most accurate astronomical and geographical calculation of the ancient Indian world. While the terminology were becoming more scientific, the ancient Indian scholars were also developing a grand philosophical framework for the universe, which they called the Brahman. They describe it as something immense and vast, a concept that actually aligns quite well with our modern understanding of the sheer scale of space. But they weren't just thinking about the heaven. They were incredibly precise about Earth as well. Their cosmography divided the world into various deepas or continents. While this was often presented in a symbolic layout, it represented a serious effort to categorize the known world and the surrounding oceans. Specifically, when they describe Bharatvarsha or the Indian subcontinent, their level of detail was remarkable. They didn't just list places, they document the intricate mountain system, the great river basin, and even the specific flora and fauna that define the region. This wasn't just folklore, it was a comprehensive regional geography that integrated the physical environment with the cultural landscape. It shows us that even in antiquity, Indian scholars viewed Earth as an interconnected system of land, water, and life. When we look at the sky through the eyes of the ancient Indian scholars, we see a science that was incredibly advanced for its time. Even as far back as Rig Veda, there was a clear cataloging of the heaven, not just sun and moon, but five distinct planets and 27 constellations. By the Puranic period, that was defined as the Navagraha system. While Rahu and Ketu were often discussed in mythological context today, for ancient astronomers, they represent the mathematically calculated points where orbits of the sun and the moon intersect. The nodes where eclipses actually happen. Now, speaking of eclipse, this is where Indian geography and astronomy really shine. Rather than viewing grahana or eclipse as a supernatural omen, scholars like Aryabhatta recognized them as a simple matter of shadow. They understood that a lunar eclipse was the Earth's shadow falling on Moon. But perhaps the most stunning achievement was their work in geodesy, the measurement of the Earth itself. Using sophisticated mathematics, the authors of Surya Siddhanta and later Aryabhatta calculate the dimensions of our planet. When you compare their estimates to the modern satellite verified data, the margin of error is incredibly small. It proves that their understanding of the Earth wasn't just philosophical, it was based on rigorous, repeatable mathematical observations. As we dive deeper into the technical side of Indian geography, we see that scholars were already grappling with the problem of location. Long before the modern GPS, classical Indian astronomers were utilizing akshansha and deshantra, what we today call latitude and longitudes. They understood that to truly map a place, you just couldn't describe it. You needed a mathematical coordinate to place it on the Earth's surface. This precision began with basics. In Rig Veda, we find the formalization of the four cardinal directions. These weren't just for navigation, they were essential for the alignment of sacred architecture and astronomical observatories. But what I find most fascinating in their early intuition was regarding geology. They didn't view the Earth as a static, unchanging object. They characterized the crust based on its physical properties, distinguishing between rocky, clay-based, and sandy terrains. Even more impressive was their theory on the Earth's origin. Centuries before Western science formalized the nebular hypothesis, the scholars were thinking that the Earth began as a gaseous matter and reached its current form through a long process of solidification. It's a remarkably modern way of thinking about the evolution of our planet, moving from ethereal to physical. As we shift our focus to the Chinese contribution, we encounter a completely different philosophical starting point. While the Greeks often viewed nature as something to be conquered or dissected from outside, the Chinese philosophers saw no such divide. To them, humans were an integral part of the nature, not observers but participants. This perspective was deeply influenced by Confucianism. It wasn't just a religion or a philosophy, it was a way of life. By minimizing social friction and emphasizing duty, it created a stable environment where the state could systematically study and manage its vast territories. The administrative efficiency led to the creation of Yukong, or the Tribute of Yu. This is the oldest known piece of Chinese geographical writing, and it's remarkably practical. It wasn't interested in myth, it was a rigorous survey of the 9 provinces of ancient China. It catalogued everything: what the soil was like, what crops grew where, and what resources each province could provide to the empire. It shows us that Chinese geography was, from very birth, a science of regional management and economic reality. While the Western world was still centuries away from formalizing its scientific methods, the Chinese were already masters of quantitative geography. They understood that you cannot manage an empire unless you can measure it. As early as the 2nd century BC, the Chinese engineers were measuring the silt level of the great rivers. This wasn't just a curious observation, it was a matter of survival, as they needed to predict how fast riverbeds would rise and where the next devastating flood might occur. In terms of human geography, the achievement of the year 2nd AD is staggering. The Chinese state carried out the first population census of the world. They understood that place isn't just about land, it's about the people who are inhabiting it. This data allowed for unprecedented social and economic planning. They also applied this precision to the sky. By developing instruments to measure rain and snow, they turned weather from a mystery into a variable measure. This empirical mindset allowed them to crack one of the nature's biggest code. By the 4th century, they had clear understanding of hydrological cycle. They knew that water wasn't just appearing or disappearing, it was moving in a continuous cycle in nature. This level of physical science gave the Chinese a significant advantage in agricultural engineering and disaster prevention. As we continue, we see the Chinese geography was moving towards a sophisticated understanding of both ecology and geology. The philosopher Meng Zhu offered that what we might consider today as one of the first lessons on environmental conservation. He observed that once a forest is cleared, it isn't just cutting of trees that stops the growth. It's the grazing of cattle and goats on the slope that prevents the forest from reseeding itself. This was a profound early insight into how human activity permanently alters the landscape. Centuries later, the polymath Shen Hua took this further into the realm of geomorphology. While observing the fossils of Taiyang Mountain, he deduced that Earth was being constantly reshaped. He theorized that mountains were being worn down by erosion, that the silts were being carried away from new land elsewhere. This was a revolutionary understanding of deep time and geological change. Finally, we must discuss Phei Hsiu, widely regarded as the father of Chinese cartography. Before him, maps were often artistic and imprecise. Hsiu changed everything by introducing a rigorous rectangular grid system. He established 6 strict principles for mapmaking, ensuring that scale and distance were calculated mathematically rather than estimated. His maps of the organized province of China became the gold standard for centuries, proving the Chinese had mastered the ability to represent the three-dimensional world on a two-dimensional surface with incredible precision. In summary, we must look at the Indian and the Chinese contribution not as isolated history, but as the two great pillars of Eastern geographical thought. On one hand, we have Indian tradition, which was profoundly mathematical. By defining the Brahman and refining the coordinates of latitude and longitude, Indian scholars provided the geometric skeleton of our world. They taught us how to measure the earth by looking at the stars, giving us a precision in geodesy that was centuries ahead of its time. On the other hand, we have the Chinese tradition, which was the master of empirical and administrative geography. They showed us that geography is the ultimate tool for governance. Through their use of rain gauge, silt measurement, and first ever census, they treated the earth as a living system that needed to be monitored and respected. The development of grid-based cartography wasn't just about drawing maps, it was about creating a reliable scientific language for space. Together, these two civilizations remind us that geography has always been a blend of the celestial and the terrestrial, a balance between the math of the heavens and the reality of the soil. That brings our exploration of ancient Indian and Chinese geographical thought to a close. In our next lecture, we will move forward in time to a pivotal figure in the history of the geographical thought, Varanius. We will examine how he began to bridge the gap between the ancient tradition and modern geography, specifically through his revolutionary distinction between general and special geography. Thank you all for your attention today. If you have any questions, please leave them in the comment box below and I'll sure to give back to you. I'll see you in the next lecture.